thank you to everybody to be here. And my name is Guido Ghisio. I'm in MAGNETI MARELLI, in charge of automated driving technologies development. The first point is why automated driving. The first answer is to increase safety. We have to remember that more than 90% of the accidents are made by the behavior of the drivers. So the drivers usually are bad drivers. And traffic management, we can optimize traffic management from the point of view of energy management and timing in the travel around the towns and different roads. Emission reduction with the connected fuel reduction consumption. Demographic change, we can cope with people that are unconfident drivers rather than to enhance mobility for elderly people. The age of people is increasing also for the driver. More, we have the possibility to put inside the vehicle new, more technologies and to give to the car maker more reason for competitiveness and innovation. Okay, next. Okay. In order to have a common understanding of what autonomous driving or automated driving is, a lot of national and international group has defined a specific levels map in order to describe how the driver contribution move from a total control to a total not control. Level 0 is the situation where we can drive the car completely. Level 1 is called assisted, and the car has the control of or longitudinal or lateral dynamic driving. Level 2, you have both longitudinal and lateral driving, but the driver should always be ready to take control. From level 3 on, you have a more authority is transferred to the vehicle. So the driver has to take control just when it is asked by the car. In level 4, you have a specific condition in which, or use case, in which you do not need to monitor, but you have to take control when the use case is over. Then you go to the fully automation situation. So today we are here and we are moving here in the commercial cars, and at the research level we are here and we are moving here and here. Google car is at this place, but it is the only one to believe to a full automation. When we speak about automation, we do not want to take out the driver from driving. We just want to allow the driver not to do repetitive or cumbersome tasks for which it's not a pleasure to drive. So, for instance, it's not a pleasure to take control that the car in front of us is always at the right distance, or it's not a pleasure to park your car. Increasing the driving automation, you can also leave the driver to drive when he decides anyway. Here are some examples. Longitudinal control is adaptive cruise control. You can see on the road all the way. And the lane keeping assistant is managed in lateral control, and parking maneuvering is what you can see in some trademark of car. If you add some or combine adaptive cruise control with lane keeping, you can have a higher level of automation because you control both longitudinal and lateral dynamic driving. And you can increase the performances with stop and go features and with higher speed. Then you can manage cross parking assistant where the vehicle gain more and more authority. If you look at the situation, today we are in level 0 and level 1, and we are moving to level 2. If you see, we take away the emergency features like ABS, ESC, electronic stability control, because they are ready today, but they intervene only in the emergency situation. So driving automation is something starting from this point. If you look to a low velocity instructor environment, you can think to highway traffic jam system. So you are in a situation where the speed is limited to 60, 70 kilometers per hour, and you follow the car in front of you, and also the steering is under control in this structured environment. If you look at higher velocity, higher speed in structured environment, you move to highway system where function like overcome, lane changer, and the other car overcome are allowed and performed. If you just go to a higher level of automation, but in a low velocity structured environment, you can perform valet parking system. Then you can think to unstructured environment, where it means that you go to urban and rural roads. If you think to the full automation, you have the robot taxi that is the target of Google. But now all the car maker and the tier 1 are focused on these three major functions: highway traffic jam system and the highway system. In highway system, you can add some function like entering and exiting from the highway, and to manage speed that are at the limit of the allowed speed, 130 kilometers. Valet parking system is one of the more interesting for the application function because every one of us has a lot of problem when he's going to a supermarket and try to park his car without going too farther away from the supermarket. From the point of view of the technologies, I beg your pardon, I start to speak with the slide in front and not with the microphone. I will take care of it. If from the technology point of view there are no big problems, or better, big problems are going to be solved, from the legal point of view, it represents one of the major slowing factor of the diffusion of automation in the car. Which is the problem? The human driver gives up control to the car, becoming a mere observer or controller. And so he has a limited power to intervene as control shifts from the driver to the vehicle. And then another question arises. Who is responsible when something goes wrong or when a crash occurs? This is really one point that is slowing activities and the insertion in production of these features. Of course, there are some trade-offs related with the different level of automation, and level 3 is made possible also in this situation because the driver can take control when something goes wrong. From the rule point of view, there are the Vienna Convention road traffic from 1966, and in green there are all the countries that take part of this convention, where by means of the point 8, Article 8, is not possible to drive a car by itself. You need always to have a human driver, and the human driver should be able to overcome the automation features. So this is not only a problem to sell vehicle, but also to test vehicle. In Europe, it is almost impossible to test vehicle, but to private trucks. There are some exceptions, of course. A car from Paris to Bordeaux transit in the highway, but it was a special permission to do that. And it was not a test, but it was something like a demonstration. Now, all these countries are working to amend this article, but up to now, nothing has been reached. A lot of commission, a lot of task force, a lot of committee are working on that, but at present, it's very difficult to test car in Europe. On the contrary, on USA, Nevada, Florida, California, and Michigan have issued positive legislation to regulate the use of autonomous vehicle by setting requirements to the vehicle themselves and the driver for testing purpose only. This is also the reason why automated driving is growing mainly in California. It is a sort of replacement of Silicon Valley from the point of view of semiconductor and automatic integrated circuit design, because there are a lot of brains and a lot of initiatives, and it is allowed to test car in public road. This is a weak point for Europe, because we do not have the same facilities from the development point of view. These are the main items that rules legal and liability problems. Is not allowed to steer as we would like, because we can steer automatically only up to 10 kilometers per hour. Vienna Convention and Geneva Convention authorize the driving with an autonomous vehicle only if there is a driver inside. So it's a contradiction. And we have national traffic laws that can be helpful to overcome Vienna Convention, but can be also cumbersome to overcome by themselves. So to legal and liability, you can think about insurance company are actually the real problem rather than the technical one. Here is a list of the enabling technologies. So if you want to take care of automatic driving, you must have these competencies and these skills. We concentrate in groups. So perception and processing of data that we have perceived. Radar, camera, LIDAR, ultrasonic device are the field of operation of these competencies. Then you have to manage precise positioning, and so you have to add a good knowledge and information related with gyro, accelerometer, odometer, and you have to manage visual odometry and to manage high-density 2D and 3D maps, and with all the problems related with maps upgrade. Today we have an upgrade of the maps, usually in the workshop, one time every 3 months or more. With automatic driving, we have to think to 1 hour, half an hour. So it's a very big item. Here we have is a partial solution of these items, information that come from vehicle to infrastructure, communication. These are the technologies, but the application, one of the first application is the map upgrades. And we need of this kind of information because with the sensor we have a specific field of view not far from 200 or 300 meters. Here we can have information about what is happening around the corner. After that we have got data, we have to refine this kind of data, define the object related with the data, and to understand the situation, and to define risk assessment, action plan, and decision making. For instance, in situation where you have to decide if go behind the car or overcome the car. You have to know how to planning the path, and you have to control the vehicle. It's not possible to take, not to consider this point, because the path planning, a theoretical one, can decide to have a lane change in time 0. All this stuff today is managed on PC computer. Now we think that embedded solution must be provided, and it means to grow competence in architecture, architecture of the vehicle with sensor and high capability of processing, data processing. Computing power, we need much more computing power than today. Data transmission network, we have to avoid latency problem. We have to be, if not instantaneous, we have to be sure of the timing. Functional safety is an item important in the embedded solution. Processing architecture, a lot of processing should be made in parallel. We have a graphic processor unit that are used no more for graphics but for computing power and power dissipation. Today, a good architecture as a demo is dissipating 100 watt, and so it's like it's okay for a demo, but not for a production. Okay, so the sensor are these: radar 24 and 77, 79 gigahertz. LiDAR is a good sensor from the point of view of the accuracy of measurement, but from the point of view of its construction is an optical and mechanical device. So the reliability of this solution is not compatible with the automotive constraints. Some Tier 1 and some car makers are planning to use them, but all of them are waiting for more reliable solution based on semiconductor, where the lobes are produced by activating and deactivating specific semiconductor. So we are waiting for a technological revolution inside this kind of sensor. Mono and stereo camera are the most flexible sensor. Flexible because the item is not optical or mechanical, but is based on the correct image processing. Image processing is doing for this sensor a good item for the diffusion. You can see that almost all car has this kind of device on behind the windshield. Ultrasounds are old, but are also cheap, and they do their work as expected. Okay, now we start from sensor, and we describe how we manage data from sensor. We take different perceptions from different sensor: camera, LiDAR, or LiDAR, and radar. Then we make a sensor fusion. So we do not make a data fusion, we make a sensor fusion. If we add maps and information from GPS, we have what we call positioning maps. If we take into account information related with communication from roads, from infrastructure to vehicle, from roadside unit to the vehicle, and from vehicle to vehicle, we get more information. And all together allow us to make data fusion. So this is a representation of, for us, is data fusion. We have different information from maps, from odometer, from communication, and we have a synthetic representation of what we see around the vehicle. We spoke about path planning and vehicle dynamics. We can explain what is route planning. Is the same of the route showed by the navigator from one point to another one. Then we have a static path planning, so we analyze the situation at a lane level. Then we manage a dynamic path planning, so we can go behind the vehicle, we can overcome. We have some cost function to be optimized. If we do like that, we have to reduce speed, and so we can save fuel and reduce pollution. If we do like that, we increase consumption, but we shorten the time and the performances of the vehicle. Then, after that we have defined the path planning, we have to manage the dynamic of the vehicle by means of the lateral control, of the longitudinal control, and all that is to get the best vehicle dynamics that give you interesting performances or just the feeling of safety in the car. If we consider the robotic paradigm like sense, think and decision, act, Magneti Marelli is now focusing his activity on think and decision. We do not produce sensor, we do not produce brake or steering wheel. We are today at this level 2, and we are moving to the level 3 and level 4. We have 2 proof of concept vehicle, and we are working on that on this item. We have defined highway and parking use case in different scenarios. So lane keeping and lane change, car following, overtaking, and merging and exit as far as regards the highway. And as far as regards the parking, outdoor parking, indoor parking, last but not least, you do not have the GPS information, and street parking, a very irregular environment. This means to have a different sensor. We choose highway and parking because they are at the opposite of speed and sensor perception. Highway, long distance and high speed. Parking, short distance and low speed. We have here a lot of sensors. This doesn't mean that we put all these sensors, but we, as a proof of concept, will define a minimum kit of sensors, and we will measure how far they are from the ideal situation that is represented here from the LIDAR measurement. So we have 2 three projects now. One is for the highway, one is for the parking, and the third is to embed all these stuff inside one board. You will see now our strategy to design. Today, up to now, we make a lot of tests on vehicles, but this is a problem for vehicles in limited numbers and scenario variety management. So we have a quite complex environment about simulation, related with also our history. Here you can see the scanner to Scanner Studio in order to define environmental condition and sensor output. In the past, we developed vehicle dynamics information about the car model, and we reuse this information here. But in the next development, we will take advantage of all the features of this simulator. Then, from as far as regards the traffic flow, we use Amsung. We feed all the information related to the environment with maps taken from here or TomTom.
Magneti Marelli approach to automated driving. The fundamental robotic paradigm is described as sense, think and decision, and actuation. Magneti Marelli has a relevant knowledge on all the three areas and focuses its activities on automated driving on the think and decision block. The Magneti Marelli Virtual Driver ECU portable solution exploits all the sensors able to interact with the environment, analyzes the collected data by fusing them, and manages the vehicle behavior. Our fully customizable product enables to safely perform automated features in the highway, such as enter in the first lane, accelerate up to the allowed speed limit, sense the differential speed with the car around, change lane and overtake, alert the driver to take back control. Thanks to Magneti Marelli's tailor-made approach, the Virtual Driver ECU gives also the possibility to leave the vehicle in the drop-off area of a parking lot and command the vehicle to park itself by using the mobile app. The system receives the parking area map via Wi-Fi and commands the navigation looking for a free parking space by deploying sensors, avoiding obstacles and pedestrians. Once recalled with the mobile app, the system drives the car back to the pickup area, allowing the driver to get in and take control. Think and Decision, portable and customizable solutions for automated driving.
So you have seen that it was a video clip in animation because for time reason it was more complex and more slow to take the pictures of the vehicle, but at the end you saw the vehicle, and so it's not just a video clip, there are vehicles behind. This is what we call a virtual driver ECU, so the intelligence of the vehicle. From the point of view of the domain controller, like powertrain, body, chassis, infotainment, doesn't change very much, but you need to have an ECU. In the video clip, you have seen an ECU, flexible, because what we means that we can cope with different sensor architecture and different communication architecture. And we are now working about this item. And this item gives some items to be solved. High performances, big memory, high computational resources, low latency with high data flow bandwidth, virtualization in a hard real-time context. Virtualization means that we have to manage function managed by Linux and by a different operating system like QNX and so on. We have to guarantee the SLD compliance, many different application suppliers, heterogeneous application with different demand, from the real-time functional safety and so on. To do that, we selected a partner with which we are working. Today, we have this kind of architecture, so smart sensor that gives information of obstacle detected or information related with positioning. In the next future, we will manage dummy sensor, so not a smart sensor, and we will have all the computational power inside the Think and Decision ECU. As you have seen, the actuator doesn't matter too much how they are organized here, sensor and computing. Further features are related to an extension of communication features, the driver monitoring system, because we have to know at the higher level how is the driver, not live or dead, but if it is attention on the item of driving. Precise positioning is another item, and cloud-based maps and services is another item that we will take into account. Thank you. I hope to be in the...
Thank you. Thank you for your presentation. Are there any questions?
Thank you for the presentation and sharing this interesting information with us. So I have just a question. You cited the problem, the legal problem, and the responsibility. Who is responsible for the car? Basically, my question is, it is clear that the capabilities of the driver to take back control is a crucial point. And the attention of the driver and who is this attention evolving in time when the driver is driving in a highway or in rural roads is critical. And is there some interest on that? Or?
Above all, the critical point is that if we leave the driver to be free to do other things, he can be ready to take control of the car, but he has to know well in advance which are the choices that the car has made. For instance, you are overcoming another car and the vehicle decides that it's too risky, and so it gives the control to the driver. So different features of driver monitoring, not only where there are the eyes or if the eyes are open or closed, but and not only a warning. It's not only a warning matter, but we have to take the driver informed about the choice of the car. So the freedom given to the driver, as showed in a lot of video clip, also YouTube and so on, is not completely true. the driver or someone in the car, I don't know if it is really the driver, has to know what the car is doing. Otherwise, he is not able to take control of the vehicle and to avoid accident or just to manage unexpected situation. In order to reduce the unexpected situation, we do a lot of simulation, but it's not enough. Thank you.
Yeah, thank you for the interesting talk. My name is Jos Bernasch. I'm from the Virtual Vehicle Research Center in Graz in Austria. You mentioned some regulations from the UN and the Vienna Convention. As far as I know, in March there was a change at the UN ECE regulation that if a car has a kind of master shift in the car, then you are allowed to use some automatic driving functions because you can change between normal mode and the automatic mode. And it's getting at the 26th of March, I think, it's now valid, so you can use these cars as far as I know. Is this true, and do you incorporate that?
Yes, I think that about Vienna Convention, a lot of things, a lot of words and a lot of wishes have been expressed. Now we are waiting, is a matter of some months, to have a real practical amendment, because up to now Vienna Convention is written as it was written in '68. Anyway, there are some exceptions related with the behavior of some European countries. Like in Germany, there is a piece of road between Berlin and München, and in France there is a piece of road from Paris to Bordeaux, where it is possible to drive with high-level automation features, but it's not really of common usage. Yeah.
I think the Vienna Convention was changed about 1 year ago, and it was enforced since March 2016, so it's already changed. Maybe we can talk in the break, but I think there's really a legal change in the Vienna Convention.
I've heard about the 26th of March of the 2016 as a date of change. But today, really, we do not see the operative rules of how to do, because for instance, in USA, you can take the plate of the autonomous driving car, but you have to pay 1 million for liability reason. And so if something strange happens, you can finance the regulation, the management of the problem.
Yeah. Okay.
Yeah.
So we are building up a car right now for that, and so we will see if this regulation really works or not. So we will we will see this in the next couple of weeks. Thank you.
Yeah. Thank you.